All right, so 5.4 is going to be polynomial division. And with any, again, if you keep up with notes, this will be notes number 4 for this second 9 weeks when we're going through everything. Today's Monday. There's two types of division we're going to do. We're going to do synthetic division. We're also going to do long division. And the big thing that you have to do is, again, the first thing that's on this sheet that we have here, and this is true for synthetic division, this is true for long division, this is true for any division that we do. But going back to this handout that we've got here, whether it's synthetic division or long division, and I'm not going to write these down because we've got it here, and actually got it twice. The terms have to be in standard form, which again is descending order based on the power of the variable. All right, and then if any variable powers are not present, then the powers must be included with a 0 coefficient. Okay, so that part is true whether it's synthetic division or long division, and those two things are important enough that I went ahead and rewrote those for step 1 that's here for synthetic, but you can also put this basically be the same thing for long division. So for any division that you do, whether it's synthetic division or long division, you have to do those two things. Everything's got to be in standard form where it's in descending order. And if there's any powers of x that's missing, you've got to go back and put a 0 in there. Okay, so first thing we're going to do is we're actually going to do type 1, which would be long division. And for this one, there's not as many problems that you're going to have to do with long division because it's a little bit different type of thing that everything that we do on the second half of the chapter is going to be using synthetic division. So that's why I've got this handout. That's where we're going to do almost everything that we're going to do is synthetic division, not long division. So what we're going to do, and then before you even do this, let me kind of take you back for just a second here. What if you were doing, and again, you don't have to write this down. This is kind of the thought process that you want here. Let's take you back to like 3rd or 4th grade. If you're dividing 45 into 9,763, we got to go back and think about the steps on this one. I can remember even being in college, and I was in Cal 2 or Cal 3, I think, and I had somebody who was working on it was an elementary education teacher, or working on elementary education, and she was like, "Hey, you're a math person, right?" I was like, "Yeah." She said, "Well, can you help me go through some long division stuff?" I was like, "Sure." And she's like, "Well, how do we do a problem like this?" And I sat there for probably about 30 seconds trying to remember how to do long division because it'd been forever since I'd done it. So I just had this blank stare on my face. I was like, well, you've got to divide. And I just kind of, it wouldn't come to me. I just sat there just kind of with a dumb look on my face because I couldn't remember how to do it. Finally, it clicked on me. I was like, well, all right, we're dividing 45. 45 won't go into 9. I was like, oh, here we go. So we put an X there. Then we go to 45 into 97. And then you have to kind of, just guess, well, that's 2 times 45 is 90. All right, now here's the thing. Where does that subtraction sign come from? It's just kind of there, right? That's just part of the formula, right? I mean, that's just something that you do. There's nowhere it comes from. You just go back in and you subtract those two numbers. You got a 7, bring down the 6. So that'll go 1 time. And again, the subtraction sign just kind of pops up out of nowhere. And then you get 45 into 313. And then you start checking. You're like, well, I don't know. Maybe that goes 7 times. You just take a guess. Well, if you do 7 times 5, that's 35. 7 times 4 is 28. Plus 3 would be 315. So that number's too big, so that wouldn't work. So then we had to dial it back to a 6 maybe. So 6 times 5 is 30. 6 times 4 is 24. Add the 3 from the 30, that'd be 270. And you subtract to get 43. Okay, so that was the old way of doing long division with numbers to kind of go through the steps on that one. When we do long division with polynomials, it's going to kind of go along that same route of the problem. So that's the thought process we've got to go through when we do one. Okay, now a couple of things you need to remember on this one. The number you divide by on the outside, that is the divisor. The number that's on the inside, that's the dividend. If you don't remember that, you may just want to write that down to remember that when you're dividing a problem, the divisor is what's on the outside, the dividend is what's on the inside, because that's a couple of things we'll talk about just to make some things a little bit easier when we talk about stuff here. All right, so here we go. So let's show you a long division problem. And again, you don't have to worry about, necessarily all this one. Just know that divisors on the outside, dividends on the inside. As long as you've got that part of it, then, we'll be okay when we set this thing up. And again, you're not going to have to worry about doing a lot of long division problems, just because everything we're going to do is synthetic division, and that's the key thing that we're doing. So we're going to worry about that more than anything else when we go through these. All right, so we're going to take 2x plus 1. We're going to divide that into 6x squared plus 7x plus 3. Okay, and if you're doing long division with polynomials, the very first thing that you're going to do is that you've got this big expression. Now, again, we've got this thing in descending order. We've got x to the first, x to the second, x to the first, and no x's, so it's in descending order. The way you're going to set this thing up and go through long division is basically you just key on the first terms. So basically we're going to take 6x squared. We're going to divide it by 2x. Okay, and the other parts of it, we're going to get to those in just a second. But to get this thing going, we're going to do that. So same thing back here. When we're dividing 45 into 9,763, we didn't worry about the back end of it to start with. We just worried about 45 into 97. Same thing with this one. We're not worried about 2x divided into all this stuff. We're just worried about 2x divided into 6x squared. So if we do that, 6 divided by 2 is 3. We've got x squared divided by x. We can knock off one of the x's, so that would be 3x. So that's the first thing that we'll put to start right here. We'll put a 3x. All right, and then we're going to multiply. We're going to do 3x times 2x to make that 6x squared. But because it's 3x times all this, we're also going to do 3x times 1, so we're going to do a little distributive property. So then we'll have a plus 3x. All right, and back here, when we're doing this one, that negative just kind of popped up out of nowhere, right? That it's not, there's nowhere that we get a negative off this thing. So what we're going to have to do is when we do long division, you've got to go back and change both of these signs. That was a positive. We're going to change it to a negative. This one was a positive. We're going to change it to a negative. All right, so now we've got 6 minus 6, which is 0, x squared, which is what we want. So now that's gone. We've got 7x minus 3x, which would be 4x. And just like we were doing division, once we've done all the subtraction, we're going to bring down that next number. So now we're going to bring down that plus 3. And then same thing again. Now we're going to key on the first term. Now we're going to take 4x and divide it by 2x. Okay, so if we do 4x divided by 2x. Okay, so 4x divided by 2x, the x's will cancel. That leaves you with just a 2. So then we put the 2 back up on top there. And then just like we did before, we're going to do 2x times 2x to make that 4x. And we're going to do 2x times 2 to make that a plus 2. And again, with that subtraction sign that popped in there, that also popped in here, we're going to do the same thing. We're going to change the signs. This one was positive. We'll change it to a negative. This one was positive. We'll change it to a negative. So that'd be 4x minus 4x, which is 0x, which is gone. And then 3 minus 2 is 1. And once you run out of numbers, that's as far as you have to go. That's all that you would have. So the final answer on this one would be 3x plus 2. And the way they're going to show the remainder in most cases is they're going to put the remainder here, and then whatever you divided by, you put that underneath the bottom to let you know what you're looking at. Okay, so that's long division. Now, for what we're going to do, you're not going to have to worry about doing probably, but maybe one problem with long division, maybe two at the most, because everything that we do from the rest of the chapter on is all going to use synthetic division. Okay, so what we're going to do is we're going to go back to, instead of writing down the notes and doing everything long for this one, we're going to show you the synthetic division on this one. Now, the key thing is that with synthetic division, when we do this one, here's the one thing that wasn't on the sheet there with the synthetic division that we're doing. This is type 2. So type 2 is going to be synthetic division. It can be used when the divisor has a coefficient of 1 on the variable. That basically you need x plus some number, or you can have x minus some number. Okay, this problem back here, you couldn't use it because the x had a coefficient of 2. So this problem, now if it was just x plus 1, then we wouldn't have to do long division. You could actually do synthetic division. So synthetic division, you can use this when the divisor has a coefficient of 1 on the variable. It has to be x plus a number, or it has to be x minus some number. If it's got a, again, that this is always just a 1 that's here. I understood 1. If it's 2 or 3 or 5 or some other number besides that, even if it's x squared, you cannot do synthetic division. It has to be x plus some number or x minus some number. And then once you have that, well, then the rest of it is we're going to go back and run through all the steps that's on this sheet that we've got and check everything off. All right, so here we go. So we're just going to give you some examples and kind of walk through this one because, again, it takes longer to go through all these steps and write all this down than it does to actually show you these problems. So that was one that after the first year or two doing this, when everybody was like, can we not just write this down? And I was like, yeah, let's do that because that's a huge shortcut. So, all right, so here we go. So we'll run through some examples and just show you how this works and let you kind of get the hang of it. And once we do 4 or 5 of them, then I think everybody should be pretty good with it. So. All right, so let's do x plus 5. And let's divide that into 4x squared plus 23x plus 16. All right, so going through our steps, the terms on the inside are in descending order, so we're good there. We didn't skip any power of x because we got x to the second, x to the first, and basically this would be nothing, so it's x to the 0 power. So for here, we're going to go through our steps. So we've got 1 done. So now 2 says draw your division bar upside down and leave a little space underneath it. So if you've got lined paper, here's basically where you make it where it's like 2 lines. I always kind of do it that way. All right, step 3 then says bring down only the coefficients. So on the inside here, on the dividend, you bring down the 4, the plus 23, and then the plus 16. And yes, you do need to bring down the signs, even if it's a plus, because it makes a difference when you go through these. All right, number 4 says on the outside, bring down the constant, which would be just the 5. But when you bring down this constant, and here's the catch on this one, we're going to change this sign on the outside. And that way, when we do that, that takes the place of changing. When we multiplied here and we did all these signs, that if we change this number around, then we basically don't have to worry about changing all these signs like we were doing back here in long division. So that's kind of the trick on this one, is that if we change this sign on the outside, we're going to do what we normally would do with long division, but we don't have to worry about changing the sign every time. All right. Says take the number that's first and put it below your division bar. So far there's no math. It's just rearranging some stuff. Now you actually have to do a little bit of math. You're going to do -5 times 4, and then put that number here, which would be negative 20. Okay, so we got negative 5 times 4 is negative 20. And then here, step 7 says you add or subtract. Whatever the signs tell you to do that. So it's 23 minus 20. Well, that's positive 3. And then we're just going to keep repeating the multiplication and the adding and subtracting until we run out of numbers. So now it's negative 5 times 3, which is negative 15. 16 minus 15 is a positive 1. And since there's no other numbers at the end, then that's where we stop. All right, now, once you're here, you're like, okay, well, how does that look anything at all like the answer we had back here when we're doing this? Okay, so here's the trick. Here's what we're going to do on this one. If we go back and do like we were talking about with synthetic division, with long division, have a keyed on the first terms, this would be 4x squared divided by x. This is always going to just knock this down a power of 1. So on this one, we're going to start with this number that's here, but whatever this power is, because we're going to divide it by x, you always start with 1 less power. So this is going to be 4x. This one's also going to be 1 less power of x. This is going to be plus 3. And the last number that's here, this is always the remainder. So then we're going to write this number, this plus 1, and we're going to put that over what we were divided by, which was the x plus 5. All right, and that should be the final answer. And I think with a lot of the online homework, a lot of these, they will just give you this. They'll go ahead and have this remainder part set up that basically you just go back and put that answer in a box. And I think they'll also have it where these are set up in boxes. And you just have to kind of go back through and put in the numbers on these. Some of them may not be exactly set that way, but I think that's kind of the main way that they'll go through with these. Okay, so again, the big thing is with synthetic division is because you're always going to divide by x, it's just going to take this first number you have and you're just going to knock it down a power. So whatever you start with x squared, it'll knock it down to x. When we do the next one, we're going to start with x to the third, just so that it starts off with a little different set of numbers here. Okay, so for this one, a little bit bigger power of x in this case. But again, steps will be exactly the same thing. So go back through and check it. We've got x to the third, x to the second, x to the first, and no x's, so that part of it's good. All right, and again, coefficient-wise, this would be a 1. That's a positive 2. That's a negative 5, and that's a positive 3. And on the outside, we're going to pull down the 2. Again, the big thing is, though, if it's negative, we're going to change it to a positive. Bring down the first number. And then here's where you finally get to do the math that comes in with this one. So now we're doing 2 times 1, which is 2. All right, 2 plus 2 is 4. And then we're going to multiply 2 times 4. So you get 8. And again, you can do negative 5 plus 8, or some people like to go backwards. If we do 8 plus 5, that would be a positive 3. And now we're going to multiply negative 2. Then we have to kind of do dash lines on this one. We're going to do positive 2 times positive 3, which would be a positive 6. And then 6 plus 3 is 9. Okay. And again, since this one started off with x to the third, you're always, for synthetic division, you always knock this down 1 power of x, so that'll make that x squared. And from there, it just goes in descending order. This will be x squared. This will be x to the first. This will be x. And that last number, again, is always your remainder. So they should write that as plus 9, and that's over x minus 2. Okay. Let's give you one more here. All right, so let's go with x plus 2. Let's divide that into x to the third minus 3x plus 4. Show you one that's a little bit different to kind of get you on the setup of it here. Okay, so here's one where you have to go, and again, going through those first two parts of it there, is again, the terms have to be in descending order, which they're good. We've got x to the third minus 3x plus 4. But it says if variable powers are not present, you've got to include those with a 0 coefficient. And here's what that means. We skipped from x to the third to x to the first. We skipped over x squared. So that's one where you have to go back then and you have to put in a 0x squared in its place. So when it talks about if there's a power of x that's missing, you've got to go back and put a 0 for that coefficient. That's basically what this thing is talking about. And sometimes it may be that there may be two numbers it may skip. It may skip over, it may be like x to the third plus 4. If that was the case, you'd put a 0 for the x squared, and you'd also put a 0 for the x in that part. So if they skip over more than one power, you've got to put more than one 0 in there to do its place. Because you'll still get an answer here. It's just not going to be the correct answer if you don't put that 0 in its place. All right, so it's going to be 1, 0, -3, and then a +4. And on the outside, instead of x plus 2, now we're going to divide this thing by -2. All right, and then from there, once you've got that set up, all the steps are exactly the same from there. Bring down that first number, and then we're going to multiply -2 times 1, and the answer would go there. The good news is with the 0, it doesn't change anything. So if this is 0 minus 2, that's still going to stay as a -2. So now we're doing -2 times -2, which would be a +4. And then 4 minus 3, or -3 plus 4, that's going to make that a +1. So then we're doing -2 times a +1, which is a -2. And then 4 minus 2 is +2. All right, and again, this one started off with x to the third, so this one will start off with 1x squared, which again, if it's 1x squared, you don't necessarily have to put that 1 in there. That'd be a -2x plus 1, and plus your remainder over what it was that you were dividing by. All right, and then one more example we're going to look at, and then we got a couple of little things at the end that we'll tack onto this one. And then once we tack on these couple of things here, then that will pretty much wrap us up for what we've got for today. Because some of these, actually, I'll show it this way. Some of the problems when they write these out to you, it may be like this, where it's -3x to the third plus 5x squared plus 10x minus 1, and then divided by x minus 3. So that they may write some of the problems, when you get these problems, it may look something like that, but just realize it's still a division problem. It's just now it's just this thing divided by this thing. So if you set this up, now we're just going to put the x minus 3 over here, and then we'll be dividing it in this way. So no matter which way and again, sometimes they'll actually make it a fraction where they'll put this part over x minus 3. It doesn't matter what you do. That again, that whatever that number is, it's the smaller part of it. That's basically going to be your divisor when you set these up. All right, it is in descending order. X to the third, x to the second, x to the first, and nothing there. All the powers are there. Didn't skip anything, so this one's good to go. We don't have to go back and plug in any zeros here. So it's -3 plus 5 plus 10 and minus 1. And then we're going to change that from a -3 to a +3. All right, actually, let's do this. Go ahead and just run through the numbers, see what you get. Take like a minute here, and see what you come up with. And then once you've had a chance to kind of check and see what you get, then we'll come back and show you what the correct answer was. Okay, so let's see what we've got. See if everybody worked out okay. So again, bringing down the first number is -3. So you've got 3 times -3, which would be a -9. We've got 5 minus 9, which would be -4. So then we're going to do 3 times -4, which would be -12. 10 minus 12 is -2. And then 3 times -2 is a -6. And -1 minus 6 is a -7. All right, so final answer there would be -3. Again, we start off with x to the third, so this one's going to bump down to x squared. Minus 4x minus 2, and then there should be a -7 over x minus 3. Okay, now here's where sometimes in years past, not necessarily on this test we would be doing, normally we'd split this chapter up into 2 tests, but a different year, so we're doing some things different. Normally we would have a second part of the test where people would get to work with partners on some different things, and you have to do a lot of synthetic division because there may be some problems where you would have to do well, probably some cases you might have to do 10 or 15 synthetic division checks. So what we'd have people do is we would have people work in partners, and that way it would kind of speed the process up to find some answers that we were looking for. So here's a check that you can do for this one. Let's say you got to the end and you were doing this one, because one of the first things I would ask on this problem was did you get an answer of -7 at the end? And if some people said no, well, then that would kind of let us know that we'd have to check it. So here's something that you can do that will be a good check. And this is what they call the remainder theorem. The remainder theorem basically is this. This is a check for synthetic division. And basically it's this. You're going to evaluate what you divided by in synthetic division which in this case would have been the +3 back here. So you evaluate what you divided by in synthetic division. You will evaluate that. Put a comma there. You evaluate that in the dividend, this thing we started with on the inside back here. And the answer should equal the remainder. So, because when we were doing this before in years past, we had a problem and they would get something that they thought was a solution, and one person would get it and check it, and they're like, well, I got this answer. And then somebody else would do it, and they were like, I got this answer. And they're like, how do we know which one's right? I was like, well, then you need to do the remainder theorem. If you get something that you get stuck on and you've got two different answers, this is the way to check and see who's got the correct answer, so you'll know who's going to be right on this one. So for a problem like this one, let's say you got to the end and somebody had -7 for the remainder and somebody else had -17 or +7 or something like that. Here's what you would do. So we're going to take this +3 that we had, and we're going to take that 3 and we're going to plug it back into -x⁻³ plus 5x² plus 10x minus 1. I'm just going to write that back down so we can see it. And we're going to let x equals, so whatever, and again, we're using whatever this number was, which in this case was a +3 in the division. We're going to plug that back in and see what we can get from this thing. We've got -3 to the 3rd power plus 5 times 3 squared plus 10 times 3 minus 1. All right, and if you've got a good calculator or even a decent calculator, then this is one where you let the calculator do the work so that you don't have to do as much of it. Okay. So we're going to do -3 times 3. Now, this one doesn't have a 3rd power button. So if you have a calculator like this, it doesn't. The rooftop or the arrow button that's right here on the Texas Instrument, if you hit that rooftop button, it gives you that. That's your power button. So that would be the 3rd. And then everything else should be able to plug it straight in like it is. Plus 5 times 3 squared plus 10 times 3 minus 1. So all that came out to be -7. And if we go back and check, that is what we had in the remainder back here. So that -7 checked with that -7, so it checks. Okay, so this would be one, again, this was something that we had to use in years past, because on the second test we would do, the last test of chapter 5, they'd have to compare answers, and this was the easiest way for them to check to know if somebody got one answer and somebody else got a different answer. This was the easiest way to kind of go back and figure out what that was. All right, now one last thing that we'll throw in here, and then we'll wrap this up for today. Kind of on that same line, if the remainder, let's say that you either do the synthetic division and you get a number here, or you do the remainder theorem and you get some number. But if the remainder equals 0, what you divided by, get it straightened up here. So if the remainder is equal to 0, what you divided by, which again is your divisor, is a factor of the dividend. So if the remainder equals 0, then what you divided by is a factor. That also tells you that if you set that factor equal to 0, then you have a solution. Okay, so it's kind of a double part. It does two things. Number one, if the remainder is equal to 0, you get a factor of it. But at the same time, if you set that factor equal to 0, then you also get a solution of it. So you kind of get two things on this one, because it depends on, sometimes they'll ask you, is this expression a factor of this thing? And again, as long as the remainder is 0, then it's a factor. Then they may also say, come back and say, all right, tell me what the solution is going to be. The kind of neat thing is that if we did a problem that had something equal to 0. Did we have one? No, we didn't have one yet, did we? Okay, so let's do this real quick. We'll do one where we get one that's equal to 0, just so you can kind of see. Okay, so this was our problem. We'd have a 1, a plus 4, plus 1, and a minus 6. And change that positive 2 to a negative 2. And then from there, we're just going to do a quick synthetic division. And again, we're doing this one just so you can kind of see what it is so that you understand exactly what's going on with this thing. All right, bringing down the first number, bringing down the 1. We've got negative 2 times 1, which would be a negative 2. 4 minus 2 is a positive 2. Negative 2 times negative 2 is a negative 4. 1 minus 4 is negative 3. And then if you do negative 2 times negative 3, that's a positive 6, which then gives us a 0. Okay, so and again, two things that this does. Again, if we got a remainder is equal to 0. If we go ahead and write out the answer here, this would be, again, bring this down 1 power of x. So instead of starting off with x to the third, that's going to be x squared plus 2x minus 3. Okay, but remainder equals 0 tells us a couple of things now. That means that x plus 2 is a factor. But then the other thing that also kind of goes with that one is that because if we did this x plus 2 and set it equal to 0, you'd see real quick that if we do x plus 2 equal to 0, we subtract 2 from both sides to get x equals negative 2. That means that this number that's here that we divided by, we'll say x equals negative 2, is a solution. So if you get remainder equals 0, you get a bunch of stuff that's going to kind of, and now again, it's not going to be a huge thing right now, but when we do the next few sections, it's going to pop up. That's something that's going to be big that they're going to ask you, okay, find another factor, of this expression, or they may say to find a solution. That basically those two things are almost interchangeable. It's just writing them a different way. That again, if you get a factor, which would be this thing, to find the solution, you just set that factor equal to 0, which is basically saying if we check this number that's here, that is checking to see if this thing is going to be a solution with it. Okay, but we'll talk about that more a little bit as we're going in the next couple of days, because that's just something we're going to build on. So we're going to keep coming back to synthetic division more tomorrow, and probably even a little bit more on the days down the road, just to kind of keep building on that same concept.